Alright, let's look at the homework 5.2, problem number 10. Alright, so you have the derivative of the number of bacteria with respect to time is given here. Alright, then we want to find the minimum value of the derivative. So we have to look for the critical number, so we take another derivative. Alright, so let's do that. So we take another derivative, so it's going to be a second derivative of capital N. With respect to time. Right? So here I'm going to let's say use the quotient rule. So we have a negative here, and 2000 is just going to be a number, so I'll just put the number in there. And here, quotient rule, and square the bottom guy, so it's a 1 plus t squared, right? Derivative of t is 1 times the bottom is 1 plus t squared minus top guy times the derivative of the bottom, well, which is 2t. Right? So if you clean that up, you get the negative 2000. Right? So it's going to be 1 plus t squared minus 2t squared. So it's going to be 1 minus t squared over 1 plus t squared, right? So in order to find a critical number, we set that equal to 0, which gives you t minus 1. So 1 minus t squared is equal to 0, right? Add t squared to both sides, so 1 has to be equal to t squared, Then we can just take the square root of both sides. So it's a plus minus 1 is the t value. But since t is between 0 and 10, obviously we pick the positive one. Right? So at the t equals 1, we're going to have probably the minimum. But just to make sure that this is going to give you the minimum. So let's do a number line. So number line between 0 and 10. Right, tick marks at 1. Right, so let's double check. So we try x equals, say, 1/2. Right, if you plug in 1/2 in here, you see that the 1 minus 1/2 squared is going to be positive. This is positive. There's a negative, so you have a negative sign here. Right, x is anything bigger than 1, so I'll try 2. If you plug in 2 here, 1 minus 4 is negative, positive, negative. So it's going to be positive. Right? So if you look at the second derivative of n with respect to t, those are the sign. So if you look at the derivative of n, you can see that this is decreasing before 1, increasing after 1. Which tells us that at the critical number 1, we're going to have a local maximum. Actually, this is going to be a global maximum, but local minimum, minimum, which is what we are looking for. All right, so let's see. Let's go back and type it in. Let's see. All right. So minimum value, okay, we have to plug in. All right, so we need to plug in. Right, evaluated at t equals 1. So you have negative 2000 times 1 over 1 plus 1 squared. Right? So that's going to be 2, so it's going to be negative 1000. Right? So we know that the answer is minimum value would be negative 1000 bacteria per millimeter per day. All right, let's check the answer. So we got that. All right, if the initial count was 6,000, and then find the original function n of t. All right, so let's do that. So let's see, then find the bacteria after 10 days. All right. All right, so I'm gonna just erase a little bit. So we have, let's see, Alright, so initial count was 6,000, so which basically tells you that n of 0 is 6,000. Right, then we want to find the n of t and n of 10. So let's do that. So in order to find the n of t, since we have the derivative, so we take the antiderivative to go back to the original function. Right, so it's going to be negative sign, and actually 2000, we can probably put that outside too. And t over 1 plus t squared. Right, dt. Alright, so let's use a substitution here. I'm going to use this, do a substitution here. Let u is equal to 1 plus t squared, which is the bottom guy right here. Alright, then take the derivative of u with respect to t. We have 2t. Alright, then take the reciprocal of both sides. We have dt over du is equal to 1 over 2t. Then we can multiply both sides by du to get the dt is equal to du over 2t. Alright, so if you do a substitution here, so you have a negative, right? Then you have a 2000t over, we decided to call the whole denominator u, and dt is equivalent to du over 2t. Right? So you can see that we can cancel 2t and the 2000t, so you have a 1000 left over. Right? So you're going to get negative 1000, and the antiderivative of 1 over u is natural log of absolute value of u, and then plus some constant c. Right? Then we're going to put the original expression back in. So you have a negative 1000 natural log of absolute value of 1 plus t squared plus c. Right? Then we know that the n of 0 is 6000. So we compute that. So it's going to be negative 1000. Right? Then you have a natural log of 1 plus 0, so it's going to be natural log of 1, which is 0, plus c. Right? So remember that the natural log of 1 is 0, so it's just going to be c, right? Which is equal to 6000. Right? So therefore, n of t is this function, negative 1000 natural log of absolute value of 1 plus t squared, and we found out that the c is 6000. Right? So let's type it in. Right? N of t is negative 1000, right? Natural log of 1 plus t squared, and in this case we don't really need the absolute value sign because 1 plus t squared is never negative, so you have plus 6000. Right? Let's check the answer. Alright, we got that. Alright, after 10 days, so t is in days, I hope. Let's see, so in days, so we just have to find n of 10. So here, n of 10 is equal to negative 1000 natural log of 10 squared plus 1, so it's 101 plus 6000. Right? So let's use GeoGebra to compute that. So it's negative 1000 and natural log of 101 plus 6000 is equal to, right? It's a 1385. So that's if after 10 days. What's the precision there? Right, approximately, so 1,300, I forgot the number, and 85, right, 85, right, so let's check the answer. Alright, we got that. Alright, so when, let's see, two decimal places, bacteria count 2,000 bacteria per millimeter. Alright, so let's do that. Alright, so we just need to, running out of space, but let's set that equal to, so n of t is right here. So n of t is negative 1000 natural log of 1 plus t squared plus 6000, and we want this guy to be 2000, right? So set that equal to 2000, right? So by subtracting 6000 from both sides, we have negative 1000 natural log of 1 plus t squared is equal to negative 4000, right? And divide through by negative 1000, so I'm going to just do it right here. So you're going to get positive 4, right? Then we can raise e to both sides to cancel out the natural log. So you're going to have 1 plus t squared is equal to e to the 4th power, right? Then we can subtract 1 from both sides. So t squared is equal to e to the 4th minus 1, right? Then we can just take the square root of both sides. T is equal to plus or minus square root of e to the 4th minus 1, right? But since we're talking about time, so we know that it's going to be the positive 1, right? So let's see, it's going to be round to nearest hundredth, okay? So we just have to compute this value. So it's square root of e to the 4th power, e to the 4th power minus 1, right? So actually, maybe I have to do exp of 4 minus 1, right? Then hit enter, right? 7.32, right? So answer is 7.32 days, right? Check the answer. You got that? All right, that's it. I hope that this was clear.